A chemical tanker of 45,000 deadweight tonnage has completed loading and is ready to sail. It is a UMS-class vessel with bridge control. The pilot boards the vessel, and the main engine is tried out satisfactorily. Vessel casts off at 8:36 hours. Tugs assist the vessel in maneuvering until it reaches the river passage. The tugs are then released, and the vessel continues maneuvering. On sighting a ship approaching from the starboard, the pilot requests for stop movement at 8:40 hours. At 8:45 hours, pilot requests for a dead slow astern. Engine fails to respond. Movements are given, both in ahead and in astern directions, but engine fails to respond again. At 8:48 hours, the controls are changed over from bridge to the engine control room. Movements are given in both directions. Engine fails to respond from both engine control room and emergency stand. At 8:55 hours, Chief Engineer informs Master that the engines have failed and starts troubleshooting. At 9 hours, the Master informs the pilot about the engine failure, and then the Chief Engineer was attending to the problem. The pilot requested for the anchor to be dropped. The pilot tells the Master that he has to report the matter to Port State Control if the engines are not ready within 10 minutes. Pilot informs PSC at 9:10 hours. The vessel is put on restrictive detention immediately by PSC. Master informs DPA and Technical Superintendent. Actual case. The Chief Engineer informs Superintendent that automatic main has stopped and actuator is not operating. The actuator was dismantled and overhauled. After removing the O-rings of the actuator, its movement was tried out in the workshop and found satisfactory. The time lost in overhauling was 5 hours. The actuator was fitted back on the air start valve and tried out again. Air pressure for operating the actuator was not sufficient. Fault was traced to pneumatic valves number 27 and 28 in maneuvering system. Valve number 27 was renewed, and valve number 28 was overhauled, but was not performing satisfactorily. There was no spare valve for valve number 28. The superintendent was contacted to arrange for a new valve 28. Superintendent arranges for a service engineer, who arrives with a new valve 36 hours later. The service engineer replaces the valve 28, as per Chief Engineer's advice. The main engine was tried out from all 3 locations in the presence of class surveyor and post-state control inspector, and was found working satisfactory. The vessel then proceeds on its outbound voyage. The total expense incurred from the time the vessel retained till it resumes the passage was $73,575. The root cause of the problem was later diagnosed as absence of control air dehydrator, which resulted in impurities being carried into the pneumatic system. The same problem had occurred 8 months earlier, but no remedial action was taken by the office. Preventive measure. Good practice with troubleshooting will help in identifying and solving the problem. However, only a complete analysis of all control inputs and outputs can help the superintendent to identify the root cause.